As a railway maintainer, you don't want the assets you look after to fail. This slows down or stops trains, which then leads to delayed and unhappy passengers, followed closely by angry phone calls from bosses asking what has happened. Trust me, I've been there. The problem is, trying to work out when something is about to go wrong and getting there to fix it before it does is really difficult. In this video, we're going to look at how remote condition monitoring has given railway engineers this ability and how it has changed the way railways are run and maintained. We're going to look at how traditional inspection regimes work, the issues these created, then look at how the use of remote condition monitoring has changed approaches to maintenance, as well as the challenges that might arise when implementing RCM. Before we dive into the video, let me introduce you to this video's sponsor, Connox. Their mission is to help railway infrastructure owners and maintainers increase capacity, reliability, and cost efficiency, all with the goal of making rail the primary transport choice for everyone. Connox applies state-of-the-art data science, machine learning, and AI to the mountain of underutilized railway data. This data, covering individual assets and network conditions, holds huge value and can be used to optimize maintenance planning, resource allocation, operations, and capacity. Switch is Connox's predictive maintenance solution for switch and crossing layouts. It continuously monitors and analyzes the health of key components, such as the track bed, crossings, and points operating equipment. It then provides real-time insights and feedback to maintainers and infrastructure owners on the optimal time and type of maintenance required, while also indicating potential failures before they happen. As you'll see in this video, Connox's Switch really is at the cutting edge of remote condition monitoring solutions. Click the link in the top right or in the description below to learn more about Connox's solutions and how they're transforming railway maintenance. For a long time, railway assets have been maintained through scheduled inspections at set intervals. The frequency of these inspections varies depending on the asset's usage, but these adjustments are still based largely on high-level estimations rather than precise data for that individual asset. There is typically one major inspection and maintenance visit per year, supplemented by periodic minor inspection. The idea is that these visits identify issues early, allowing for planned corrective actions within a suitable timeframe. This approach also assumes that maintenance is carried out to a high enough standard to keep the asset operational until the next inspection. This approach has been applied to all types of railway assets: plain line track, switches, overhead line, and transformers, to name a few. So what is missing from this approach? Well, these inspections only provide a snapshot in time. The asset can be perfect when you walk away from it, but then something could change. In the short term, factors such as weather, environmental conditions, or foreign objects on the track can cause damage that gradually worsens. In the long term, changes in train traffic patterns or rolling stock types may introduce new stresses on the infrastructure. However, if the inspection regime is only reviewed annually, inspection frequencies may not be adjusted in time to detect emerging issues. But what happens when something does go wrong? A set of points fails to swing properly, or a train driver reports that a section of track has suddenly become very rough to ride over. The issue is reported, and the maintainer receives a call to attend. However, they often have little to no information about the likely cause, or sometimes even the exact location of the problem. So off you set on a bit of a voyage of discovery. Once you arrive, you need site access to locate and diagnose the issue, carry out repairs, and possibly conduct follow-up inspections after trains have passed. That's a lot of unknowns. What parts or materials you might need, what tools, where to start looking for the issue, how long it could take to fix, what the risk is of running trains in the intervening time. This might sound like a bleak picture, perhaps more so than is fair. Maintainers do have systems in place to manage these challenges, and experienced staff can quickly identify common failure patterns and causes. However, the key takeaway is this approach remains entirely reactive. Everything happens after the asset has already failed. So, how do we get ahead of these issues and become proactive? That's where remote condition monitoring comes in. Remote condition monitoring, or RCM as it's known, and we will call it that from here on in, is a system that collects data from sensors on the asset, providing real-time insights into its health and performance. The key components of RCM are sensors, data transmission, and analysis. Sensors are installed on the track and directly on railway assets. The most common application I've encountered is on points, particularly within points operating equipment. These sensors collect data on parameters such as the current drawn by motors or the time taken for points to move across. Data transmission is crucial, as the collected information and data must reach those who can act on it reliably. This often means sending data to a signal box or another central hub, where signallers, maintainers and operational staff can assess the information and respond accordingly. Lastly, and arguably most importantly, is the analysis of the incoming data. Without this step, whether performed by a person, a computer program or AI, the data remains just that, raw data. It is the analysis that gives it value. Identifying patterns or anomalies, such as spikes in current or an increase in motor runtime, can signal potential issues like insufficient slide chair lubrication or a minor obstruction in the points. Crucially, this analysis can be continuously refined as new patterns emerge and are linked to specific failure modes, getting better all the time. But this sounds like a lot to get in place, right? So what are the benefits? First and foremost, RCM addresses the problem highlighted earlier in this video. It puts maintainers on the front foot, allowing them to be proactive in identifying and resolving issues before they disrupt train services. This in itself brings a cost saving, as train delays can be avoided. Even if they do fail, the data analysis can help identify likely causes, therefore leading to reduced rectification times. The trending of the data over time can also allow asset managers to make informed choices on which assets might need renewal or components that are the root cause of multiple issues. Then there is the improvement in safety for both passengers and railway staff. Potentially hazardous issues can be detected early and resolved before they become serious risks. For railway staff, this means less time on track in reactive situations where pressure and stress levels are high and access conditions may be less than ideal. Planning earlier interventions is always preferable. The final benefit is operational efficiency, which ties together several of the previous points. RCM reduces disruptions to train operations by enabling proactive maintenance. When an issue is detected, maintenance access can be scheduled strategically to minimise the impact on the timetable. So while the benefits of RCM are huge, it does come with some challenges and limitations. Before we look at these, I just wanted to say that if you're interested in railway engineering, then I have a free PDF guide that might interest you. Cant is one of the most fundamental rail concepts when it comes to track geometry, and I cover it in depth in my free Guide to Cant PDF. You can get your free copy at the link in the top right hand corner now, or in the description below. Get started on your railway engineering journey now. So, the challenges. The first challenge is cost. Implementing RCM requires a substantial investment in equipment, installation, and its ongoing management. Additionally, it depends on a reliable data network to transmit the information to where it's needed. Upgrading this infrastructure can be a major expense in itself. Another challenge is the expertise required to interpret the data and take the appropriate action. Implementing RCM represents a fundamental shift in how the railway operates, and adapting to this change may take time. So let's look at some examples of where RCM is already in use. Earlier in this video, I mentioned points operating equipment as an example. Since switches and junctions as a whole are crucial components of any rail network, detecting potential failures early has a significant impact on the reliability and performance of the network overall. Civil engineers use monitoring systems on bridges, tunnels and embankments to detect and measure structural movement. On the track, rail temperature sensors eliminate the need for watchmen to manually record temperatures during hot weather. Additionally, remote void meters can detect vertical track movement in crucial areas, such as sites with formation failure or repeat twist geometry faults. These are just a few examples that I've come across. Let me know in the comments if you've seen other uses of RCM in the railway. So what does the future hold for RCM? I think it's fair to say that while RCM is already used extensively, its use is only going to increase even further. The use of AI and other predictive analytics techniques will increase the accuracy of data analysis, improving decision making. The use of drones and new sensors technologies will expand both the range of data collected and the locations where monitoring can take place. It will also change the way that maintenance is planned and delivered. Railways are likely to move away from set frequency inspections towards data-led maintenance. On screen now is another video that I think you'll find interesting. Please do give this video a like, drop any questions in the comments below, and don't forget to hit that subscribe button.